Hello everyone, welcome to our Math 126 course, and this will be Pre-Calculus 1, and we will go through 30 sections of this course in your textbook. And before we delve deep into the details of the mathematics covered in the first section, which would be section 1.1, I wanted to go through some topics with you about how to study this subject, because over the past 18 or 19 years that I've taught this subject, the main reason, the main obstacle for my students has always been not knowing how to study this subject. They are fully capable of doing extremely well in this topic at any level, but they just don't know how to approach studying this subject. So I want to spend maybe 5 or 10 minutes just talking about that before we start the mathematics portion of this video. So the first thing, and this goes for any quantitative subjects such as physics, chemistry, economics, or finance, any quantitative subject, the first thing you want to do is study the section before it's covered in class. And it doesn't matter if you fully understand everything that is being said. That doesn't matter at all. It's just whether you're aware of it or not, when you read text, your mind starts picking up material from that reading that will later connect when you sit in a lecture. So it's very, very important to skim through this section before it is covered in class. So that would be the first one. Skim through a textbook section. Or topic before it is covered in class. All right, maybe I should have written that in red, but let me underline it. Before it is covered in class. The second thing you want to do, attend each class. Don't miss it. Don't miss any class. Attend each class. Okay, so attend the lecture and take notes that would be useful to you. This is important because you and your best friend might be taking the same course here, but he or she might walk out of each lecture with 5 pages of notes, and you might walk out of each lecture with 2.5 pages of notes. So you're taking notes, each of you is taking notes on the stuff that you know it's important to you, that you might forget later. So you're taking notes on things that you know that you need to know more than other topics. And the third thing, review your lecture notes, the ones that you took when you're attending the class. Review your lecture notes and solve all the problems without looking at the solutions. Very, very important. So when you take notes, you don't want to archive these notes. Just by taking notes, it doesn't mean that you automatically absorb the content. So how do you make sure that you understand those notes? What you do is you review them, review those notes, but this time, as you go through each of the examples that your teachers solve for you in the class, without looking at the solutions. So you've taken notes, you already have the solutions, but don't look at the solutions, because that would be memorizing somebody else's work, somebody else's thinking and approach. You want to solve these problems on your own, because that will force you to generate your own thinking. And that's critical. That's number one when you learn anything. You ought to have the opportunity, or you ought to give yourself the opportunity to generate your own thinking. If you rob yourself away from that, you will not learn anything. So give yourself the opportunity to solve each problem without looking at anybody else's solution. Whether it's my solution or your best friend's or classmate's solution, solve it on your own. Once you have finished it, and again, it doesn't matter if your solution is wrong, and it doesn't matter if you think your solution is wrong, but solve it with your own thinking, with your own approach and what you know. Once you've done that, then look at the solutions that you took notes on in class, or some other a tutor's notes, let's say. But always approach a tutor with your questions with your own solutions. You do not want to toss out your own solutions. Always work the problems out on your own, and then keep those solutions. Take them to your tutor, bring them to my office hours, and then when you have your solutions already, then I can comment on your thinking, which will be very productive in terms of you learning the topic. So that's what you want to do after taking the lecture notes. And then number 4, you want to complete all homework assignments by the due date. So you do not want to procrastinate. So this is critical, because homework assignments, those problems are picked with insight and intention of teaching you those subjects, relying on what we know about what kinds of errors students tend to make. So with that experience in mind, we pick these questions for problems for the assignments. So as you go through these, you're building that knowledge that will prevent you from making mistakes that would cause not doing well in this class. So homework assignments are pretty critical. And last step, review. Very, very important. So you do want to go through all these steps. Maybe step 1, you could, if the first time when you skimmed through the textbook section, maybe it took you an hour. By the way, it should not take you, this step should not take you more than an hour before attending the lecture. So suppose the first time it took you 45 minutes to go through this first step, and then now when you review, it might take you 10 minutes or less, because you already know the material and you're just making sure that there isn't something that you've forgotten. And then go through all of this, look at your lecture notes again, maybe not solve all the problems, but pick some problems that gave you difficulty the first time. See if you can solve them again with relative ease. If you can, then you're really learning the material. And of course, the lecture notes and then the homework assignments are set up so you can always go back and look at them again just for a review or just for a quick glance to refresh your mind about these topics. Okay, so these steps, I mean, review. Right now, I go through material in mathematics in courses that I'm not even teaching. But I do that because I want to make sure that when I am assigned to teach these subjects, then my mind is fresh. I can hit the ground running, so to speak. Okay, so these are not steps that I'm just recommending to you, but these are especially this last one is the step that I do for the courses that I am teaching or not teaching. I constantly review that material. Okay, so having talked about that, which is the most important thing in learning any quantitative subject, let's begin with section 1.1. So this course is filled with properties and rules that you need to remember right off the bat. I mean, a big part of practicing in class and practicing with homework is to help you remember these formulas, properties, and rules without even thinking about them even 2 seconds. So right off the bat, you should be able to remember them. If you don't remember them, then really, really easy problems become very difficult for you to solve because you don't remember these properties or rules. We will be talking about properties of exponents, properties of radical expressions, rules of rationalizing the denominator, and so on. You want to be able to remember these. We're going to be talking about special product formulas. These special product formulas are critical when you factor mathematical expressions, and if you don't remember them, then you will get stuck. So it's very important for you to remember these properties and rules as we go through them. So here are on the first page of the worksheet. By the way, all these worksheets are on Canvas, the blank ones, so you can always download them and solve those problems on your own and then compare them with the videos that you have from me. Okay, so this one, each of these has names. It's not important to remember the names of these, but it's very important for you to remember what these rules basically say. So if you have A plus B equals B plus A times B equals B times A. Some of these are obvious, aren't they? For example, 5 times 2 is the same thing as 2 times 5, which is basically what this formula is saying. And all of these A plus B plus C is equal to A plus B plus C. So if you remove the parentheses, it's not going to change anything. And if you have A times B times C, that's equivalent or identical to A times B times C. This one, these last two are critical because this is about the distributive property. Very, very important. So one of the most common errors that I see is that people, when they have a number in front of a parenthesis, they distribute it to the first term, but not the second or the third or the fourth term if there are more terms inside the parenthesis. So any entity in front of a parenthesis, whether it's a number or a negative sign, it belongs or it distributes itself into all the terms inside the parentheses. So A times B plus C is AB plus AC, the distributive property. Very important. This is the same thing as the top equation. Again, it's a distributive property, but this time the A is placed after the parentheses. But it makes no difference in how you would distribute the A into these two terms. Okay, this again, these are all these are all important, but the ones that are especially important, I'm going to box. So this minus in front, it means that minus multiplies itself by what's inside the parentheses. People think this minus means subtracting from this. No, it's a minus in front of a parenthesis distributes itself or multiplies itself into what comes after it. Okay, so it's not a subtraction symbol, it's a multiple. This is a -1 multiplying itself by what comes after it. In here, we have minus a times b, or minus, you can move this minus from term to term. It will not make any difference in the result. So all of these terms are equivalent to each other or identical to each other. So this one, a minus number times another negative number, a negative number times another negative number is positive. Why? Because anytime you have even number of negative numbers multiplying by each other, then the result is going to be a positive number. Again, anytime you have even number of negative numbers being multiplied, the result is going to be a positive number. So if you have two negative numbers multiplying by each other, you're going to get a positive answer. If you have 4, 6, 8, 10, 12, 14, on and on, any even number of negative numbers multiplied, you'll get a positive result. So this is again, this property is again the distributive property, but this time it applies to two terms. That one was the minus was multiplying itself by just one term, but this one, it's multiplying itself by two terms. So that minus represents -1, multiplying itself by a, and then multiplying itself again by b, minus a minus b. Okay? And if you have a minus in front with the middle sign being negative, then this -1 multiplies itself through these terms inside the parentheses and changes the algebraic sign for those. So a was positive, now it's negative. B was negative, now it's positive. Okay? And you can rewrite this. You can rewrite this so it looks different visually, but mathematically is exactly the same thing. So instead of minus a plus b, you can rewrite it so the minus is in the middle between the two. B minus a. These two are identical. Okay? So more properties of fractions this time. If you have two fractions being multiplied, you can simply multiply the numerator and divide by the product of the denominator. So a lot of what I'm going through here, a lot of what I'm showing you here has nothing to do with numbers and math part of it. It has to do with visually how we can manipulate things, these symbols visually. So as you read through this, or as you watch this video, try to get a visual sense about what's happening here. Okay? And then this one, when we add two fractions, the first fraction stays the same, a over b, then change the division to multiplication symbol. That dot represents multiplication. And flip the second fraction. So instead of c over d, now we have d over c. Okay? So the first fraction times, rather than divide, times, flip the second fraction. And then multiply just like you did above. So a times d divided by b times c. Here, we're taking the common denominator in this example. So c is already a common denominator between these two fractions. So that means we can either add, in this case, or subtract the numerators. We will never subtract or add the denominators. We always add or subtract the numerators depending on if we have a common denominator. Okay? Here, the denominator obviously was not common like the previous example, right? So b and d suggest different denominators. So we need to form the common denominator. One way of forming the common denominator is take the product of those two. So if you do that here, then multiply each numerator by what's missing from its denominator when you compare it with the common denominator. So let me say that again. When you take the common denominator, multiply each numerator by the term from the common denominator that is missing from the denominator of the original fraction. So BD is the common denominator, right? So D is missing from this denominator, so multiply its numerator by the missing part, which is D. From this denominator, B is missing. So multiply the numerator by the missing piece, which is B. So BC. And then AC over BC is equal to A over B. So the reason is we can cancel C here because A and C are being multiplied and divided by B times C. So we could not, however, you could not, this is one of the most common errors that I see. Let me write it here on a piece of scratch paper. If you have A plus C divided by B plus C, this is equal to A plus C over B plus C. You cannot simplify C here. You can simplify or cancel C here because A and C are being multiplied and B and C are being multiplied here and being divided. So that's why you can cancel out C, because it's being multiplied by the terms in the numerator and the denominator. But you could not cancel C here. That's one of the most common errors that I see, and I don't know where it's coming from. It's not coming from the textbooks. I'm sure any previous classes you took, nobody talked about this like that, that this can be done. So you cannot cancel C's here. So this is still equals that. You cannot cancel C here. But here you can because A and C and B and C are being multiplied. Okay. So here are more properties, this time with the absolute value. So if you have an absolute value, and we'll get to this more, we'll see more examples of this later. But if you're solving for something that is within the absolute value, you have no choice but to remove the absolute value in order to solve for the variable that is within it. So when you remove the absolute value, you're going to end up with two solutions, not one. And this is saying absolute value of A is equal to A if A is greater than or equal to 0, which means if A is positive, then absolute value is a neutral operator, so it doesn't do anything because A is already positive. But if A is something negative, say minus 5, then removing the absolute value would be equal to minus 5 or minus A. So which means you would still get a positive value, which you should, because this is coming from an absolute value. Okay? So whenever you solve for any variable that is within an absolute value, you're going to end up with two possible solutions. Okay? We will, like I said, we will have more to say about that in the coming sections. So this is another property of absolute values, which is absolute value of AB. You can break it up into two separate absolute value terms being multiplied by each other. Okay? And this one says that if you have absolute value of A over B, you can split that absolute value into absolute value of A divided by absolute value of B. So again, try to understand these visually. A lot of these, what these properties are saying, is a visual pattern or visual rule that we have to follow. So it's a visual rule. Make sure that you remember that. Okay, so here are a couple of examples. If you have absolute value of minus 2, that's equal to 2. Absolute value of negative 3 plus 5 minus 2 plus 4 equals 4. So first add all the terms inside the absolute value and then apply the absolute value. Sometimes, one time I had a very similar question on an exam, and a substantial portion of the students answered this. They answered this as equals 14, right? Instead of saying 4, they said 14. And it took me a while to figure out why people answering 14 to this. Then it dawned on me that people first look at this one and say, oh, absolute value makes every negative number positive. So then they look at this equation and they say, oh, absolute value of negative 3 is positive 3. Absolute value of positive 5 is 5. Absolute value of negative 2 is 2. Absolute value of 4 is 4. So add all the positive numbers, you get 14. So they applied, I learned that what had tripped them off was that, okay, so they applied the absolute value into each term before adding them. No, that's not how the order of operation works. The order of operation says that first you add the numbers on the inside of the absolute value, then you apply the absolute value to that final number. So this is not correct. This is not correct. That one, this is correct. Okay. Okay, so these are the first exercises. It says that write the sets of numbers between, but not including 3 and 5 using the set notation, the interval notation, and a graph along the number line. So it's basically, this question is asking us to make the same statement in 3 different ways. And 3 different, one of them is graphical, the other one is symbolic and using interval notation. The other one is also symbolic but using a different notation, set notation. Okay, so the way the set notation works is that this set is equal to this set, but not, so it's saying that write the sets of numbers between, but not including 3, and 5, using the set notation. Okay, so that would be, open the curly brace, x, a vertical bar. A vertical bar means such that. So x, such that x is between but not including 3 and 5. There. So now x, and of course I have to close the braces there, curly brace. So x such that x is some number between 3 and 5, not including 3 and 5. Not including means that we cannot put an equality symbol under the strict inequality. Okay, that way x cannot be equal to 3 or cannot be equal to 5, but it can be any number between those 2 limits, 3 and 5. By the way, how many numbers are there between 3 and 5? Infinitely many, right? If you said infinitely many, you're absolutely correct. So the interval notation. The interval notation is basically, I'm sure you've seen this before, it involves either brackets or parentheses. Because 3 and 5 are not included, so we open with open parentheses, 3, comma, 5. Now I know you've seen this as this kind of symbolism as identifying the coordinates of a point within the xy plane. So that is a different topic. In here, when you're giving the set of numbers and using the interval notation, not including 2 numbers, that's how you would give that notation. So this is an interval notation. If the question said include 3, I would make this parentheses a bracket. A bracket means the number that comes after it is part of a solution, is part of an interval. Okay? And if it said include both 3 and 5, then I would put 2 brackets rather than parentheses around 3 and 5. Oh, so then they want us to graph this. Okay. So to graph this set using the real number line, so we know that the real number line goes from negative infinity to infinity. And we know that the 0 is in the middle. So this is between 3 and 5, but not including 3 and 5. So 1, 2, 3, 4, 5. Because 3 and 5 are not included, I'm going to, not that. I'm going to put a hollow circle here. 1, that's 1, 2, 3, and 5. All right? So put a hollow circle right where you have 3 and 5 to suggest that 3 and 5 are not included, and then make the line in between them a little bit thicker. So what you see here is the graphical representation of that interval. Okay. This one, write the interval that, notice this interval 3 is excluded from the solution because it's got a parenthesis next to it. 7 is included because it's got a bracket next to it. So write the interval 3, 7 as an inequality and draw its graph along the real number line. So it says that write it using an inequality notation. Okay, so using an inequality, that would be x, some number between 3 and 7, but x can be equal to 7. So that's part of the answer. When they say write this as an inequality, there you have it. So 7 is included because I know that because of the bracket next to it. So I show that with the equality symbol under it. See, we couldn't use the equality here and here because 3 and 5 were not included. But here, 7 is included because we know there is a bracket next to it. 3 is not included because 3 has a parenthesis next to it. And parenthesis means that 3 is not part of this interval. It's not part of the solution. But anything larger than 3 is. So 3.00001, is that part of the interval? Yes. 3.000000005, is that part of this interval? Yes. Anything over 3 is part of this interval, but not 3 itself. Also, it wants us to graph along this, graph this interval along the real number line. So let's do that. Once again, this starts from negative infinity to infinity. And 0 is in the middle here. And so 3 and 7, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3 would be that. See, 3 is not included, right, because of the parentheses. So I'm going to put a hollow circle right there. That's 3. But 7, 4, 5, 6, 7, is that included? Yes, because of the bracket. So I'm going to put a filled in circle here. And then, of course, this interval is anything between those two numbers as well. So I'm going to thicken that area of the solution between those two endpoints. Okay. So if a number is included at the end, put a filled in circle. If it's not included, leave it as a hollow circle. Okay, so here we want to simplify some expressions. This makes use of a lot of rules and properties we learned in Math 124. So it says simplify the following expression. Okay, so this is equal to, and by the way, throughout this course, I might forget to mention this. When I do remember, I will say it. But if I do forget it, please, you guys remember that throughout these videos, whenever we get to a juncture like this, pause the video. Don't look at my solutions. Grab a piece of scratch paper, write down your own solution. When you've done that, then come back to the video and see what I've done. Okay? That way you'll learn. You don't want to keep watching the video and just copying down what I do. Okay? So please pause the video, solve this, and then come back. As a matter of fact, because all these worksheets, the blank ones, are posted on Canvas, you can download them and read through them, solve the problems, then watch the video. That would be another approach too. Okay, whatever works for you, see what works best for you. Okay. All right. So this we can quickly simplify, but let me not skip a step. So minus 9 times 5 times y divided by 3. That's what we really have. Okay, so now 3 is a common factor of 9. So this, and we end up with minus 3 here. So the final result is minus 3, 3 times 5, which is minus 15 times y. Like that. Okay, so I'm just going to double check. Yeah, minus 15y. So this one, we want to distribute this. So, and I'm assuming that you paused the video, you've already have your solution in front of you, and you're comparing it with my solution. Okay, so here, distributing the minus 4/3. Distribute, then simplify. Don't do both at the same time. I've seen so many people make an error because they distribute and simplify at the same time. Whenever you do two things at once, it increases the likelihood of you making an error. So please take it step by step. First distribute, but don't simplify, which is what I've done. And then minus 4/3 times minus 9y. Minus times minus is positive. We have 4/3 times 9. See? I didn't simplify anything. I simply distributed. Now I'm going to simplify. So to do that, we have 3 is a common factor of 12. And so then now let's multiply minus 4 times minus 4 times positive 4x is minus 16x. Okay. And then this the second term, we have 3 is a common factor of 9. So we're left with 3, and we're left with 1 here. So 4 times 3 y, and I forgot to write down the y there. So let me, this would be minus 4/3 times that is positive 4/3 9y. Like that. Okay, so 4 times 3 is 12y. Like that. Can we simplify this more? Yes, we could. We could factor out the 4 from this. And so, or factor out negative 4. Makes no difference. Minus 4 times 4x minus 3y. Okay. All right. So I hope this is starting to make sense. So factoring is the opposite of the distributive property. So when you factor out anything, to check to see if you factored properly, just redistribute this term on the outside to the terms on the inside. If you get what you started with, then your factorization is correct. If you don't get that, then you have to correct or you have to change something in your factorization. Okay. Okay, here we have 7a times everything in this parentheses. So to simplify, simply distribute. 7a times b is 7ab. Okay, 7a times c is 7ac, and 7a times minus 3d is minus 21ad. Okay, so that's the final answer. Can we combine any of these? No, because A, B, A, C, and AD are totally different. Okay, so the part D, this is a problem of taking the common denominator. So what would be the common denominator in this case? You could, for example, say 10 times 18 or 180. 180 could be a common denominator for this. You can. But the other way of finding the common denominator is find the, which we call it least common denominator, which is the smallest number that can be used as the common denominator between 10 and 18, would be to find the prime factorization of each denominator. So prime factors, so 10 has prime factors 2 times 5, 18 has prime factors 3 times 3 times 2. Then once you have the prime factorization, then the least common denominator would be each of these factors, any of these factors, taken in the larger number of times it happens. So 2 happens once under this factorization, and it happens once here. So the LCD is going to have 2 only once. 3 happens twice here, so we need to include it twice, or in the largest number of times it appears under any given factor, times 5, which happens only once. So the least common denominator in this case is 9, 18, and that would be 5 times 18 would be 90, I believe. Yes, 90. Okay, so 90 is the common denominator. So then we got to get neither one of these denominators are 90. So we got to get those denominators to 90, right? So 3 over 10, we multiply it by 9 over 9 plus 7 over 18. To get this denominator to become 90, we multiply it by 5 over 5. Okay, so then what do we have? We're going to have 90 as our common denominator, but now we're going to have 3 times 9, or 27, and 7 times 5, or 35. So adding those terms in the numerator, we have 27, we have 42 and 62 over 90. Can we simplify this? Sure. We can simplify this with 2 as a common factor. So we get 31 divided by 45. Okay, and that is the final answer here. Okay, we do the same thing here. So, but this time I'm going to let you guys find the common prime factors here in order to find the LCD. So 8 has common factors 2 and 2. So 2 cubed, right? And 9 has common factors 3, prime factors, not common factors, prime factors 3 and 3. So 2 times 2, which is 8, times 3, so 72. 72 is the LCD here. So we have In this case, let me write it here. So LCD is equal to 18 here. 72. No, I was thinking about something else. 72. LCD is 72. And so let's use that then. We have 1/8 times, we need to get our denominators to be 72, times 9/9 plus 1/9 times 8/8. Okay, so the common denominator is 72. 1 times 9 is 9, plus 8 times 1 is 8. Notice the denominators is just a common denominator. We don't add or subtract the denominator. It's the numerator that we add or subtract if we have a common denominator. So we end up with 17/72. Okay, like that. Okay, so this one. And I'm hoping you're pausing the video and writing down your own solution before looking at what I have. Okay, so in this case, we have, once again, we need to take the common denominator, right? The common denominator, or the LCD for these two, is, let's see, 45, right? So the LCD is 45. So then let's get, that means each of these denominators, we need to get them to that point, to becoming 45. So the 4/5 has to be multiplied by 9/9 to give us the LCD, right? So our objective is to get the LCD for each of these fractions, but we can't multiply just the denominator and not do the same thing to the numerator. So any number that gives us the common denominator is the same number we multiply the numerator by. Okay? And then minus 5/9 multiplied by, what number do we need to give us 45 from 9? 5, right? We got to multiply the 9 by 5, but we can't just stop there. We have to multiply the numerator by 5 as well. So what do we end up with? We end up with the common denominator, which is 45, all right? And then 4 times 9 is 36, minus 5 times 5 is 25. So in the end, we end up with positive 11 divided by 45. Can we simplify this any further? No. So this is where we stop. Oh, so this one is 3 fractions that we need to add. So let's do that. So the common, or the LCD for all these 3, so the prime factorization of this 2 has denominator 1, right? So that multiplied by anything, it doesn't matter. So 8 has prime factors 2 times 2 times 2, right? We said that earlier. 6 has prime factors 2 times 3. 2 happens in larger number of times under this denominator, 3 times. But it happens only once here. So LCD will have to include the 2 in the largest number of times it occurs in any of these denominators. So in this case, 3 times. So we include 2 3 times here. 2 times 2 times 2. I'm finding the LCD. And 6 has prime factors 2 and 3. So we already have included 2 in the largest number of times it occurs. So 3 we still have to include, times 3, right? So that 8 times 3, the LCD for this case is 24. Okay, so that means we got to get each of these denominators, the 1, the 8, the 6, to becoming equal to 24. So let's do that. So 2 over 1, the denominator here is 1, right? Multiplied by, how do we get this denominator to be 24? Well, we multiply it by 24. But we can't stop there. We have to multiply the numerator by 24 as well, right? Plus 7 over 8. How are we going to get this denominator to 24? Well, multiply it by 3, right? But we have to multiply the numerator by 3 as well. Okay, minus 5 over 6. Well, how are we going to get this 6 to be 24? We multiply it by 4, but also multiply the numerator by 4. Okay, so now for all of these, note that we have a common denominator. Fantastic. That means we can add or subtract the numerators. But what are the numerators? This one is 2 times 24, or 48, plus 7 times 3 is 21, minus 5 times 4 is 20, right? Minus 20. So 21 minus 20 is positive 1, plus 48 is 49 over 24. Do these two have any common factors? Let's see. Nope, they don't. So that's where we leave the final answer. Otherwise, we would simplify it. Okay, so this part H, it's a distributive. First, we need to distribute. Then we need to combine the different fractions, the two fractions. So let's distribute, then simplify. Let's not do them at once. So 4/3 times 27 minus 4/3, which is coming from outside, times 3/4. So this minus here, I've accounted for it here. So we don't have to have it there anymore. Okay, so can we simplify things here? Absolutely. 3 is a factor of 27. We are left with 9. And 3 and 3 cancel. So we end up with 9 times 4, which is 36, minus 4 over 4, right? After the 3's are gone, we're going to end up with minus 4 divided by 4. So they'll also, they all cancel out too. So we have 36 minus 1, or 35. Okay, let's do that here. So here, what we need to do first is, in this algebra, a lot of what we're doing is basic algebra. In algebra, there is always more than one way, or I should say there's usually more than one way to answer a question or to simplify an expression. Here, you can FOIL it. You can say 9 times 1 minus 2/3 times 9, and then 1/5 times 1 and minus 1/5 times 2/3. You can FOIL it. But another way of answering this is first take the common denominator within each parenthesis. Once you have combined the fractions inside each parenthesis, then you can multiply them. So let's do that. It depends on your preference. If you want to FOIL it, that's also an acceptable way. But it takes a little bit longer to do it that way. Okay, so 9 and 9 has denominator 1, right? And the common denominator inside this parenthesis is, of course, 5. So we need to get this 1 to 5, so multiply it by 5. We have to multiply the numerator by 5 as well. Plus 1/5 times nothing, right? It's already the common denominator. So times nothing. And let's take the common denominator here as well. 1 over 1 times the common denominator here is 3. So multiplied by 3 over 3. Then minus 2/3 doesn't need to be multiplied by anything, right? because it already has the common denominator. Okay, so let's see what we have. Inside, 9 times 5 is 45. 45 plus 1 is 46 over 5 times, this is 3 minus 2, 1 over 3. So 1 over 3. Okay, so what do we end up with here? We end up with 46 over 15. Then, do they have anything in common? It doesn't look like it. So, could 3 be a factor of 46? No, it can't. So we say 46 over 15 is the final answer there. Okay. All right. So let's see. This one, there's a special formula that says if you have, recall the, you can, in this case, maybe there's at least 3 different ways of simplifying this expression. At least 3 different ways. So I'm mentioning one way, which we haven't talked about yet, but this comes from the special product. Recall the special product, or if you haven't seen this before, you can learn about it now. Recall the special product that if you have a minus b times a plus b, that is equal to a squared minus b squared. So that's a shortcut formula. So that's exactly the situation we have here, right? A in our case is 1/3, and b in our case is 1/5. So if a minus b times a plus b, if you have that, then we can use this formula. So this formula speeds things up. That's all. So if you don't remember it, you just FOIL this, or you take the common denominator like what I did up here. You take the common denominator within each parenthesis and then you multiply them. That's one way. But this speeds things up, in my opinion. So, and we'll be making use of this special product formula a lot. So this means that the result of this can be written as 1/3 squared minus 1/5 squared. So we have 1/9 from this minus 1/25. Okay, so we can definitely take the common denominator here. The common denominator would be, let's see, 5 and 5 and 3 and 3. So this would be 5. So it's 9 times 25. Let's see what that value is. So we have, to find the common denominator, 9 times 25. So 225. Okay, so to obtain the common denominator for 1/9, what do we have to multiply it by? What do we have to multiply 9 by? By 25. But we have to do this to the numerator as well. Then comes the minus, the 1/25. What do we have to multiply it by to get 225? 9, right? 9/9. Okay, so now we have 25 times 1, 25. So we have, let's see, 25 and 225 was our denominator. 25 minus 9, because minus 1 times 9 is 9, minus 9. So it'll be 25 minus 9, that's 16, positive 16 over 225. So let's see. Do these two, can we simplify this anymore? Let's see. So 218 and 45. No, 8 is not a factor of 225. 2 is not a factor of 225. And 4 is not. Is 4 is a common? No, 4, not even 4 is a common factor. So this is where we have to leave it. We cannot simplify this more than what it is. Okay. Okay. So complex fractions. Complex fractions are interesting because they are fractions within a fraction, right? And we can't leave them like that. We ought to simplify them. So there are, just like everything else that I've talked about so far, the way I simplified these previous expressions is not the only way to simplify them. You can simplify them any other valid method that you know if it leads to the same final answer. So with complex fractions, first let's take the common denominator for the numerator and then for the denominator. So we have the common denominator here would be 5, right? So 5, and then multiply the 2, which is the numerator. The denominator is 1. The denominator of 2 is 1. So multiply the numerator by what's missing from its denominator when you compare it with the common denominator. So that would be 5. So 5 times 2 is 10, minus this fraction that doesn't need multiplying by anything. So 4 over 5. Here, let me, for the benefit of those of you who might not know what's going on here, let me put this piece. So we have 2 over 1, right? And the common denominator is 5. So we need to multiply that fraction by 5 over 5 in order to give this the denominator we want. Then minus 4 over 5 doesn't need to be multiplied by anything because the denominator is already 5. So 5 is the common denominator. 2 times 5 is 10 minus 4 over 5. I'm going to simplify this, but I wanted to show you how I got this. And this one, let me put that information here. I'm going to take the common denominator. So we have, the common denominator would be 6, right? So 1/2 times 3 over 3 will give us the denominator 6 for this fraction. Then for the other, for minus 1/3, we want to multiply it by a number to get 6, and that would be 2, but we have to do the same thing to the numerator. So then we have 6 as the common denominator. Then we have 1 times 3 is 3, minus 1 times 2 is minus 1 times 2 is 2, right? Okay, so I'm going to put this here. 3 minus 2 over 6. So now you know where these numbers are coming from. That comes from that, and this comes from that. I'm trying to not to make this page too crowded. At the same time, I want to show you what's going on. Okay, so now let's simplify things. 10 minus 4 is 6 over 5 divided by 1 over 6. So to simplify a complex fraction, the easiest way is note which numbers or terms are farthest away from each other, 6 and 6, right? Multiply them and put them in the numerator. Notice which terms are nearest each other, closest to each other, 5 and 1. So 5 times 1, like that. Okay, and put them in the denominator. So multiply the farthest terms, put them in the numerator, multiply the nearest terms, put them in the denominator. You get 36 over 5, and we are done. Okay. For the next one, please make sure that you solve this on your own, this one, and then when you're done, come back to this and see how I'm doing it. Okay. All right. So once again here, like I say, this is not the only way, but it's one way to solve complex fractions. All right, so I'm going to take the common denominator for those two terms in the numerator and these two terms in the denominator. So taking the common denominator for these two, what's the common denominator? Can you tell? It's 4, right? So you have 3 over 4, which doesn't need multiplying by anything because the denominator is already 4. But this one does. So plus 1 over 2. To get 2 to be 4, we have to multiply it by 2. But hey, we got to do it to the numerator as well. So now we have, this will be 4, the common denominator, and it's going to be 3 plus 2. Right? 1 times 2 is just 2. The common denominator in here for these two terms, 1 over 12 plus 3 over 9. So let's see. The prime factors of 12 are 2 times 2 times 3. So 2 occurs twice, 3 occurs once. And then the 9 has prime factors 3 and 3. Right? So we have 2 and 2, 4, but 3, I have to take it from the denominator that has the 3 in larger number of factors. So 3 times 3, 9 times 2 times 2, and that'll be 36. So LCD is 36. That means we need to get these denominators to become 36. So to do that, plus 3 over 9 times 4 over 4, right? That is equal to 36. So 1 times 3 is 3, and 3 times 4 is 12. So let's put all of that together here. So we have equals 3 plus 2 over 4 divided by 3 plus 12 over 36. Let me quickly check here just to make sure. Plus 2, it looks okay. 5 over 4, and then this one 36, 3 plus 12, 15, correct. So let's simplify. We have 5 over 4 divided by 15 over 36. Okay, so now this is a complex fraction. We need to simplify it. I mentioned how we should do it, right? Do you remember what we need to do? So take look at the terms that are farthest away from each other, 5 and 36. Multiply them and put them in the numerator. Look at the terms that are closest to each other, 4 and 15, right? So multiply them and put them in the denominator, like that. Can we simplify this fraction? Absolutely we can. So 5 goes away, and then 5 is left with 3, right? The 5 of 15 and that 5 cancel out. 4 goes away. Instead, we end up with so that we are left with 1 there. 4 goes away, we're left with 1, and with 4 factor of this, we're left with 9. And then 9 times 1 is 9, over 3 times 1 is 3, so we end up with 3. 9 over 3, right? 3. Okay, so sets and their notations. These are very important because they keep coming up again and again, these set notations, union and intersection. What you see here, this symbol is called the union. So that symbol is called the union, and it refers to any number that's either in A, so any element or number in A, or B, or both. That's what that symbol means, this union symbol means. Any element that's either part of set A or part of set B or both. It's part of both. The intersection, that one, that symbol, is called the intersection. And it refers to any element common among sets. Okay, so that's the definition. So anything that is only in both sets or 3 sets. If you're taking the intersection of more than one set, then that would be, say if you have 4 sets, the intersection of all 4 sets is anything, any element that is present in all 4 sets. So we are given the 3 sets, A, B, and C. So A union B, that means anything that is part of A or B or both. So that's everything. So another way of saying everything is the union event. So that is equal to a new set. So A union B is a new set, and it's got 1, 2, it's got everything in A and B basically. So 1, 2, 3, 4, 5, 6, 7, and 9, right? That's A union B. Now A intersection B is only any element here that is common to both sets. So is 1 part of B? No. So it's not part of this. So it cannot be part of the intersection. Is 2 part of B? No. 3? Yes. 4? No. 5? Yes. 7? Yes. Not 9, right? 9 belongs to B but not A. So A intersection B would be 3, 5, and 7. And that's it. Only those 2 digits. Okay, so this one, number 5, it says if A is a set such that X is some value greater than or equal to -7. So it could be -7, it could be -6, it could be -6.5, -6.2. It could be all of those all the way to a positive infinity. Anything equal to or greater than -7 is part of this set A. With respect to B, anything that is less than +5 is part of that set. And with respect to C, anything that is between but not equal to -1 and 6 but equal to 6. So anything between -1 and 6 such that X can be equal to 6 but not equal to -1. Okay, so A intersection C is asking us to find anything that is common to both A and C. So a good way of finding that, you can either find it symbolically, or you can draw a graph and see where it leads. So I'm just going to do that. Suppose you have this real number line, and here we have 0. X greater than or equal to -7 would be something like that, with that being -7. Right? And then, so we have, let's see. And then on the other side, so that's, I could just continue that arrow. Now for C, it is any number between -1 and 6, including 6, but not excluding -1. So -1 would be somewhere here. Let me put it on a hollow circle. And 6, let's say here. So this one, the C translates into this, and A translates into this, that continues on that side. So where are they intersecting? At which point they are both the same? Well, they are the same, and then let me put -1 here and +6 here. They overlap because the intersection is the overlapping piece. So they overlap at or in this interval. They are, I want to give the answer using the interval notation. Well, I'll give it both, using the interval notation and the sets and the set notation that we have here. So I'll give it both ways. So this would be -1, and it can't be -1, right? So -1 and x less than or equal to 6. That's it. So that's the interval, that's the inequality notation for that, which is the same thing as that, which is okay because we're looking for the intersection. That's the only place the two sets overlap or the same, okay, not outside of this. And then also we can say A intersection C is equal to X such that X is between -1 and less than or equal to 6. So it's the same thing. A intersection C is equal to C, which is fine because that's where the two sets A and C overlap. Okay. A union B. So A union B suggests that this is everything. Any element that is part of A or B or both. Okay, so let's draw a real number line here. So -7 would be once again here, and it can be, A says X can be equal to -7, so it would be that way, and B is anything less than 5. So this is -7, anything less than 5 but not equal to 5. So this is going that way. And I have a hollow circle here because X can be anything less than 5. So A union B is basically all of that. So this is going this way, that is going that way, and if you take them together, either in A or B, you end up with -infinity to infinity. So -infinity to infinity. Okay, or you can say, since they're giving us the set notation, or X such that well, let me not include that. So X such that X is between negative infinity, and positive infinity, like that. Okay. Number 5, or number 6, sorry, that's page 5, but number 6, express the interval this in terms of an inequality and draw it using the real number line. Okay. In terms of inequality, this would be x, any value between and equal to 1 and infinity. So the infinity side always gets the strict inequality, which is what you see here, without the equality under it, always. Whether they say it or not, it doesn't matter, okay, because we can never reach infinity. So that is that. That is in terms of inequality. And then draw it using the real number line. Okay, let's do that. Okay, so we have anything that is equal to, let's say that is 1, and 1 is included because of this equality. X can be equal to 1, so I'm going to fill it in and like that, and anything greater than 1 all the way to infinity. So I'm going to use my thicker marker here and show the solution like that. So that including the 1 is the solution of that in graphical form. Okay, so this one, it says express the interval this in terms of an inequality and draw it using the real number line. Okay, so let's do that. So once again, in terms of an inequality means that x is greater than negative infinity but less than negative 6, like that. And then using the real number line, right? So we have negative 6. Let's say that's negative 6, and negative 6 is not included because of the parentheses right next to negative 6. That means negative 6 is not part of the solution. So I'm going to show that with a hollow circle. And of course, anything less than that. So anything to the left. Again, I'm going to use my thicker marker here to draw that. Like that. And finally, these two. So express the interval this using the interval notation. So interval notation is different than the inequality notation that we used here. So interval notation would be bracket, -3. Bracket because -3 is included. Because of this equality, it gets the bracket. -3, comma, anything greater than that. So positive infinity, and the infinity side always gets the parentheses, like that. So that is our interval notation for that. And draw it using the real number line. So the real number line negative infinity to infinity is 0 here, and so this would be -3 would be here. Notice it is included, so I'm going to put a filled in circle where -3 is. and anything larger than that, right? So then I'm going to use my thicker marker to thicken this line a little bit, like that. And they want us to graph this last question. They want us to graph this set. Okay? So, which means draw the real number line graph for it. Okay? So, here we have 0. 5 would be, let's say, 1, 2, 3, 4, 5. 5 is included because it's got a bracket next to it. So I'm going to put a filled-in circle there with 5. So this solution is going that way because anything equal to 5 or less than that, right? That's coming from here. All of this would be part of the solution of that one. Intersection 3, 7. 1, 2, 3. And it's got a parenthesis next to it. So I'm going to put a hollow circle right where the 3 is and comma 7. 4, 5, 6, 7. Another hollow circle there. So if I connect these two with this red line, and that one, the arrow, shows that that solution continues forever. And notice we're looking for the intersection, not the union, right? Intersection means we're looking for anything that is common to both this interval and that interval, to both. When you look at this graph, what is common to both sets? Well, it's this piece. Let me thicken it. That piece only. So to write that down, so that solution is from parenthesis 3 to comma 5, and then bracket. Okay, so that's the graph of that interval. Okay, we've come to the conclusion of this first video on section 1.1. Thank you for persisting through this. Please don't forget the study tips that I gave you at the beginning of this video and continue with that for the rest of the semester. For now, have a very nice day, and I'll see you all next time.